So now in this video, we're going to make a voltage ramp. We already started the process. We have a steady current charging the capacitor. Therefore, we have a steady voltage rise. Power source is set to 8 volts. I'm going to try to pause it right on the line there. We have a 1000 microfarad capacitor. So if we give it 1 milliamp of current, we can expect 1 volt per second right there. And we're going to get about 6 seconds worth. 1, 2, 3, 4, 5, 6. You can see 1, 2, 3, 4, 5, 6 volts there. But as we get closer to the supply voltage, it starts cutting down current and it starts curving down. But you can see for a long time, a relatively long time, we're getting a steady voltage rise. So now I unpause the oscilloscope there. We're going to see what happens when we instantly discharge the capacitor. So on the schematic I'll show later, it has a mechanical switch schematic symbol, but we're just using a jumper as a mechanical switch. I'm going to turn the light off. You're going to see a big spark right there. And there we go. So when you instantly discharge the capacitor, you get a spark, especially at higher voltages, higher value capacitors. This 1000 microfarad capacitor is really about the limit you want to start shorting it. So now we're going to go about half the value. This is a 470 microfarad capacitor, and we're going to swap places with it. There you can see the 1000 microfarad. So they're about the same size, probably because this one can be charged to a higher voltage. But again, we already got a big enough spark with this voltage. So you got to make sure the negative side, these are polarized, goes to the negative side of the circuit, which going to the negative or ground is the easiest way to do that. So there you can see voltage is going up much quicker, and let's try to pause it right there, and you can see that after a second we went up about 2 volts, another second about 2 volts, so twice as fast. Pretty reliable there. So now the schematic symbol is usually a circled arrow right there for a current source, and if there's a specific current they want you to be aware of, they usually write that value there. That may include the voltage that powers it too. That might be included with the symbol, but in any case, we got 1 milliamp of current. That's 1/1000th of an amp. Charging 1000 microfarad capacitor, that's 1/1000th of a farad. That's how it works out, that it's 1 volt per second. If it was 1 amp charging a 1 farad supercapacitor, you would get still 1 volt per second, but there'd be a lot more stored charge. That's why it's a supercapacitor. You would not short that, and you're probably limited to about 2.7 volts total. But in any case, when we drop the capacitance in half, then the voltage rose faster. We could have doubled the current, and the voltage would have rose twice as fast. So now I built my 1 milliamp current circuitry there in the last video, so I'm just going to briefly mention what it is just in case you didn't see it. So that's a J310 JFET transistor. I'm going to remove that. You could see that was going towards the negative supply through the capacitor if we didn't have the jumper. But in any case, that's the gate down there, and up here is the source. So current goes through drain, and then source, that had to go through that resistance. That's ultimately what set the current, because the gate is monitoring the voltage across those 2 points. That's a much more complex topic. We're going to keep these videos in this series very simple. But ultimately, it sets the voltage across the resistance, and then the resistance sets the current, as long as you got enough supply voltage to overcome the voltage built up by the capacitor. So that's it for this video. Thanks for watching.